This is lesson 5.2. I can identify zeros of the function by factoring and using the zero product property in graphing calculator. So for example 1 here, we're going to practice factoring. This is the same kind of factoring we did in Unit 4. So first look for a common factor. Notice x is a common factor there. Dividing x, we get x squared minus 2x minus 15. This can be factored further. We can factor this middle trinomial. The c value goes on the left. The b value goes on the right. Two numbers that multiply to get negative 15 and add to get negative 2. That works out. So we could rewrite this with the x in front and then the x minus 5, x plus 3 as our second and third factors. Part B, we look again for a common factor. 6 and x are the common factor here. Dividing this by 6x, we get x squared. Dividing 6x by 6x, we get 1. Now this can be factored further. If you recall, this is in the form of a squared minus b squared, which factors into a plus b, a minus b. So we wind up with 6x times x plus 1, x minus 1. So now that we practiced factoring, we can recall how that relates to finding the zeros or solutions or x-intercepts. All of those mean the same thing. So zeros is the same thing as x-intercepts, which is the same thing as solutions. I'm going to rewrite this so it's on one line. Y equals x plus 2, x minus 1, x minus 3. The zero product property helps us find the zeros. So we would replace this y with a 0. And then set each one of these factors equal to 0, recalling that anything times 0 is 0. So x plus 2 equals 0, x minus 1 equals 0, and x minus 3 equals 0. Subtracting 2 from both sides, we get x equals negative 2. Adding 1, we get x equals 1. And adding 3, we get x equals 3. So now we have our three x-intercepts, negative 2, 1, and 3. The next thing we do on this is to look for our lead coefficient. So we notice this would be an x times an x times an x. So our lead coefficient would be, I'm going to write that down, lead coefficient would be x cubed. So our lead coefficient is found by multiplying each one of our first terms in the sets of parentheses. So that's x times x times x, which is x cubed, which is odd and positive, which would indicate that we have a graph that is down on the left for the end behavior. Our end behavior of our graph is down on the left, up on the right. So we've plotted our three zeros. The next thing we can do to help get a better feel, since we know it's down here and up here, is to go ahead and get out the graphing calculator. You can actually type it in just as it's written in the parentheses and all, and hit graph, and you can see our graph is going to look something like this. So it's a sketch, so it doesn't have to be exact, but we get something like this, where you see the end behavior down on left, up on right, and going through the zeros. For example 3, we'll write a polynomial function from its zeros. What is a cubic polynomial function in standard form with zeros negative 2, 2, and 3. You'll recall to write these as factors, we can set up an equation, so that would look like x plus 2. We do the opposite, x minus 2 and x minus 3. To get in standard form, we then FOIL it out. So we're going to start with the x plus 2 and the x minus 2. You'll notice that that is in the form of a plus b, a minus b. So again, we talked about that on the front. A plus b, a minus b is equal to a squared minus b squared. Noticing that pattern, I could FOIL it out and I would end up with the same thing, but that's going to equal x squared minus 4. Now I'm going to take my x squared minus 4 and multiply that by my x minus 3. X squared times x is x cubed. X squared times negative 3 is a minus 3x squared. We've got a minus 4x and a plus 12. Because these are not like terms, this is our final answer, standard form, given these zeros. What is the quartic? So that means we'll have a degree 4 polynomial function in standard form with these zeros. Something that stands out right away is I have this pair again, just like I had in this previous question. So I'm going to go ahead and write those next to each other since they simplify to a binomial, which is helpful. So I'm going to write this as x minus 2, x plus 2, and then I'm going to write my other, so this opposite is going to be x plus 2, and then the opposite for that 0 is going to be an x minus 3. I know this pair right here is going to FOIL into x squared minus 4. Now I'm going to multiply that by my x plus 2. Distributing, I get x to the third plus 2x squared minus 4x minus 8. And now I need to multiply that by my last group here. So I'm going to multiply that times my x minus 3. We've got, I'm going to try and use some different colors here. The x cubed is my first term, and I'm going to multiply that by my x. So we'll get x to the fourth. And then my x cubed times my minus 3 is going to be a minus 3x cubed. And then come inside and do my 2x squared. Multiply that by both terms here. So I'm going to get a plus 2x cubed. And then I'm going to get 2 times negative 3 is minus 6. And then we've got that x squared there. And then I'm going to come back to my minus 4x. Here and multiply that, and I've got a minus 4x times an x, that's going to be a minus 4x squared, and then a minus 4x times a minus 3 is going to be a plus 12x, and then lastly I've got my minus 8, multiply that, and I've got a minus 8x and a plus 24. Now to combine like terms, it's helpful to go back through and just underline with the number of underlines that matches the degree. There's only one x to the fourth, but we've got an x cubed here, an x cubed here, and it looks like that's it. So that's going to be a minus 1x cubed or minus x cubed. We've got our x squareds. They happen to be next to each other as well, so it's going to be a minus 6 and a minus 4 is a minus 10x squared. And then we've got our x's next to each other, so a plus 12x and a minus 8x is going to be a plus 4x. And then we've got our plus 24 constant at the end. So our quartic, again this degree 4, is called a quartic.